All right, so with this horizontal, or with this vector A, the horizontal component is 2, vertical component 3. We have that here and here, and also here and here. So if you look at this, it's just a right triangle. To find the magnitude is the length of A. So I'm just doing 2 squared plus 3 squared square root. That's going to give me a magnitude of A. So that'll be square root of 4 plus 9 is 13. A has a magnitude of square root of 13. That's it. So here's same vector, except now we have an angle here, theta, against a right triangle. Use SOHCAHTOA. So here we have opposite and adjacent. So we're using tangent. And to find an angle, it's going to be inverse tangent. So we're doing inverse tangent of opposite over adjacent, 3 over 2. And when we do that, calculator here, we get 56.3. So now what we know is the length of A is square root of 13, and its direction is 56 degrees, 56.3 degrees. Now here's an example problem. We want to find the magnitude and direction. So magnitude is usually the easier one because we have a right triangle here. And so this will be what, 3, that's 5. So we're doing square root of 3 squared plus 5 squared, and that'll give us 9 plus 25, was that 34, square root of 34. So that's my magnitude. Now we need the direction. So if you notice, we are not in this first quadrant here. So the math is going to be the same, but the ending is going to be a little bit different. We're in quadrant 2. And so we can find this angle. What we do is tangent again. So it'll be inverse tangent, opposite over adjacent, 5 over 3. And that will give me 59 degrees, 59.0 degrees. But that's just here. I want to know the direction. The direction is going from here to here, like that. So my direction would actually be 180 minus 59.0, like that. And to do that, 180 minus 59.0, so that's my direction, 121 degrees. So I have a magnitude of square root of 34, direction of 121 degrees, 121 degrees, like that. All right, next part. So here, we're doing the same thing, except if you notice, they don't give us a vector that's at the origin. So we either have to move the vector to the origin, if we have that, I think on Delta Math, you can actually move this to the origin down here. But if they don't give us a picture, we have to come up where this vector is going to end up ultimately if we put at the origin. The way we do that is we look at the initial point. This is initial, and this is the terminal at the end. You're going to do terminal minus initial. That gives you your component. So it's going to be this minus that. So 5 to 2 minus 8, 5. That's going to tell us where we end up. So 5 minus 8 is -3. And then 2 minus 5 is going to be also -3. So that's telling us our vector should end up here at -3, -3 when we start at the origin. So if you move this to the origin here, we're going to end up with this vector like that. That'll be -3, -3. So now that we're at the origin here, we can find all the components. We can find the direction. We'll go from here, like that. And then we can find the magnitude and everything we need. Here in this last part, we're given this, and we want to find if you notice, we want to find the horizontal and vertical components. And if you notice here, this is a little bit bigger than -6 over here. And it's also bigger than -3. So we need to find out exactly what is the measurements of the horizontal and vertical components. So if we were to redraw the triangle, let's put it here to see what do we know about the triangle. We know that this is 7. It's a right triangle. We know that this is 60. We can use SOHCAHTOA. So to find our x component, I'll put an x here. This is going to be, what's that? Adjacent and hypotenuse. That's going to be cosine. So I'll do cosine of 6 degrees equals adjacent over hypotenuse, x over 7. So to get x, I'll have 7 cosine 60. But we have an issue here. If I do 7 cosine 60, let's see what that equals. 7 cosine 60. That gives me 3.5. And you might think, oh, well, isn't that just our horizontal component? Technically, no, because we're going this way. Shouldn't it be negative? The reason why we got a positive is because we got this one here. We need to go all the way this way to get the right horizontal measurement. So if this is 60 here, this whole thing is 180 plus 60. So really what we have is 7 cosine, and then 180 plus 60 would be 240. And if you put that in the calculator, you will get negative 3.5. So then this is our horizontal component. So then to find the vertical component here, our y, we do the same thing. Use this angle that corresponds with this direction here. So here we would have sine of 240 equals, and you can just say y over 7, opposite over hypotenuse. So we'll end up with 7 sine 240, and that will give us our y value here. So I do 7 sine 240, we should get a negative number because we are in quadrant 3, where both values are negative. Negative 6.06. So sometimes you might see things written, let's see if I can erase some of this. Sometimes you might see values written like this. It might tell you, oh, this is 7 cosine 240. That's what this represents. And you might see this. Oh, this is 7 sine 240. So then they might say, oh, your coordinate here, give me my horizontal and my vertical component. Your horizontal component, yeah, would be 7 cosine 240. Vertical component would be 7 sine 240. And again, what that's going to equal is just what we got here and here. It's going to be negative 3.5 and then negative 6.06. So there's two ways to write it. You can either write it in the trig form or the decimal form.